Welcome to this lecture. Now we are in the journey to make the complex payload or basically the reverse shell in the upcoming lecture. But before doing that, let me just tell you the concept of a threading. It is very powerful concept in the Python and in any programming language. So just remember that if you have any processes that is running on a machine, then there will be the main thread that is executing it. So there will be the processes that is doing that program. So let me show you what I am talking about. So first of all, let me just go to my Kali Linux over here, and I'll just say that open me the PyCharm. So here I'll just create the new file, Python file. So I'll just drag this right here, and in this Mac changer, basically we have to change this file name or a folder name, but for now I'll just give you the simple example. So I'll just say demo is my file. So here you can say that if I run any program, maybe say main, and here if I just write the print statement saying hey or something like this, and now if I say that let's call me main, then you are executing your main thread. Basically this is the way to just execute the program, and you can see we are just doing one task over here. So it won't be problem if you are doing one task on the multiple core, because you are simply executing a one thread and that won't take any time. But let me say you have a multiple function to execute. So instead of function, let me just go over here and create a whole class. So let's say I have a class, and this class is one class, and we have now another class, and that class will be two class. Okay, this will be two class, and let's go over here and just define some functions. So first of all, I'll just say run is the method, and here what I'm gonna do is I'll just say that let me just print. So before printing, let me say I want to use this for loop, and I want to make the range. You know what is the use of the range? That is to create the list of the numbers, and I'll say till 50 I want this execution, and I'll just say print that is class 1. So it will just print me 50 times class 1, and I'll also define the same function over here, which is also the run method. And now what I'm gonna do is I'll just do the same task, but for now I'll just say I want this again the range, which you can clearly see will print that is class 2. So let's do this real quick. So now you can see we have these two tasks. So these tasks are heavier than before. So what you can do now is make the instances of this class, and you can simply run this method. So first of all, I'll just say 1, and this 1 will be created with this one class, and after that we'll just run this one. So before that, let me also create the 2, which is the object of this 2 class. So we have now created the object, and next thing is to run this method. So in order to run, we'll have simply that is run method, and next is to call this 2 and run method. So we are doing simple things over here, so nothing fancy. We are just creating the object and the classes of that, and basically we just see the templates over here. We're just running this run method. So you could see that it is more heavier than before. So that in the previous case we just running some function that was having the simple example, but for now we have the more tasks to do. That is, you have to first run this one and this one, and this is for the 50 times. So if I show you how this will be run, so let me just go over here and just press this demo. You'll see that it will have this class 1. First you can see the sequence over here. What it has done is basically it has just printed out the class 1 first. So you can see no class 2 has been printed over here, and after there is a execution of class 1, which is printing 50 times, it has now started printing this class 2. So you could see there is a time waste over here, because you could see our CPU or basically our processor is more capable than this. Our processor can do multiple tasks at the same time, because it is a multi-core. You can have the octa core, you can have the deca core. So there is a powerful processor available nowadays. So we are only limited to this task because it is basically not using the time sharing technique. So if you see in this any of the application that is happening in around us, basically in the Windows, if I just see the MS Office, or if I just open any game, maybe if I run any game in the Windows, then you will see there will be multiple processes running at the same time. That is available, or that is done because of the multiple processor, and that multiple processor supports multiple thread. So you can take the example, maybe I'm just gaming some, maybe I'm just playing the Counter-Strike, and you could see in the Counter-Strike there will be multiple processes running. So yeah, you can basically go around, and basically that is the movement for the player, or you can also see the enemies, and you can see the movement of different players. So that is basically the threads. So every player has its own thread there. So that is very important of the thread, because thread will now be explained as a division of the processes. So what happens is you have a main task. So let me say the task is playing the Counter-Strike. So in that Counter-Strike you will have the multiple thread. That means each player in the Counter-Strike represents a thread. So thread is a particular or a part. It is only the part of the processes, and one processes will have multiple threads. But if you run only one process, it will have the main thread and the execution, or simply the different part of a thread. So just remember that. Now what you can do with the help of thread is you can simply see in this result now, because it is time wasting our basically it is not the reliable program, because it hasn't printed something that is simultaneously. So basically we are getting the output, but it is taking more time than what our processor is capable of. So in order to make our processor works faster, we have to make use of threads. So what we'll do is we'll just run on the one thread, and we'll just make this object, or basically this run method, to work on the next thread. So thread will support the multitasking. That means you can do multiple tasks with the help of the threads. So let me say from threading, which is the class that is available to just use the thread in your project, I want to import everything. So what we have done here is from threading, which is the module. So let me go back over here and show you the threading module. So it is showing that threading is used for thread based parallelism. That means it supports the multitasking. You can do multiple things simultaneously using this threading module. So instead of just, you can go back over here, and instead of just running one by one, which was done, or which was seen over here, that is, first of all class 1 was printed, and after class 1 is done, class 2 was printed. So instead of that, we want to just print everything simultaneously. So it should print class 1 first, and class 2, and again class 1. So it doesn't matter which thread first prints, or basically which thread work, but there should be time sharing between these processes. So in order to support that multitasking and time sharing which our processor is capable of, we have to use this threading technique. So let's go back here, and you could see that we have the threading module over here. So it has shown this active count, current thread, and basically the main thread. What we are interested is maybe let's go down. You could see this daemon. We have to use of this daemon in the next lecture, where we just make our own reverse shell, and you could see that it is showing that this daemon thread is basically where you run your entire program. So if entire Python program exists, when only daemon thread are left. So this flag, we'll just learn about this when we just code, so don't worry about that. So things here is this class over here. So this class is important. You could see all of these argument, and it is saying that this constructor, which is basically the thread constructor from this threading module, should be given with this keyword argument, and we'll see about this, and about this daemon and quarks and args are basically the tuple we have seen in the packing and unpacking the arguments. And next thing is you can see this run method. So I want to show you this here. So what happened is, this is the method representing the threads activity. So if you see here, I wasn't making this run method randomly. So I could have made something like maybe method, or basically I'll say that I can make this info. If you will make this info, it is not going to work in the case of threading. So I wasn't making this run purposely, or basically I wasn't making this run method randomly, but this run method is the method of this threading class. If you could see here, it has clearly shown us this is the method which you can override. in the subclass, or basically you can go to the thread class and you can see that there you will see this run method. So what we are doing is basically there is a run method in our parent class. Now we have to just override that run and we'll just do that is our own code. Instead of running that run from the original class or basically our parent class, we'll just run that thread from our subclass. So this is overriding. So let's see how we can just implement this. So in order to implement the thread, we have imported everything from the threading class. Now we have to make use of this thread class in the subclass. So thread will be your main class or the parent class. This one will be your subclass. Let's do that for the to class, and I'll just pass again the thread. So now you can make use of the thread. So you could see now we have made use of our threads, but still it is not going to be successful, or basically this is not going to run simultaneously. Let's see if this runs or not. So let me just run the demo again. This is not going to work. You could see clearly class 1 is printed first and then class 2. It is not running simultaneously. If it has run simultaneously, or if that thread was running simultaneously, it should have gone something like class 1 over here, class 2 over here. But you can clearly see, first of all, class 1 is executed, after that class 2 was printed. That means we have not succeeded yet creating this thread. So thread are not yet created. So in order to just run this thread, you have to make use of this start method. So instead of just run method, you have to use start method. So let's see, and let's go back over here, and you could see these are the two methods that is very important. So first of all is a run method, and this is important because you have to run your program into the thread with this run method. If you make any method in the class, let's say instead of run you will say running, then this is not going to work because this method is not inside this thread class. So if you want to just override or make your program to run into the thread, it should be inside this run method, and this is compulsory, this is mandatory. And next thing is this start method. So you could see we have made the object of the classes, and in order to run this method, which is to call the run, which we normally do in the object oriented programming, is simply we'll just type the object and that method we want to call. But in the case of threading, you have to use this start method in order to run this method. So let's see how this works. So let me just run this now. It should now create us a two thread. Still this is not creating us any thread. You could clearly see that class 1 was printed first and then class 2 was again printed, but we have succeeded in making the thread if it has not printed yet. So let's see how this threading work for this larger digit, because yet we haven't created that task in order to run the thread, because it is simply going with the main thread because the task is smaller. But now let's see if the task is bigger and this is going to run our task or not. So let's see. So still you could see that now you could see over here. So there is a combination over here. If you could see here that it is saying class 2 and class 1, and basically there is in instances there is also the class 2 and class 1. Here is class 2 in the class 1. So now the task is so large that it has now created the two thread where we can make each processes to run on the independent thread. So you could see our processor is so fast now that it doesn't even take a time to print this. So let's see if there is any differences between this class 2 and class 1 time. So for that I want to make a sleep for every operation on this class. So in order to do that, we have the module that is time. From time I want to import the sleep method, and after printing every that is print from class 1 and class 2, I want to sleep maybe 1 second. So after every print I want to sleep 1 second. Let's see if this works, and we can see the two threads running together. Run the demo again, and let's go real quick. Okay, so you could see now that the two threads are running together. You can clearly see class 1, class 2, class 1, class 2. because now every time we just run that module or basically run that class or the thread, they are running simultaneously. So this is your threading technique. What we did was we just make the multiple thread in order to run the processes quickly than before. So if you just stick to the main thread, it is going to take a more time if you are doing more tasks. But if you are doing the smaller tasks, that will be really fine. But if you are doing much more tasks, or basically if you are doing very high tasks, then creating a threads running simultaneously on the thread, the processes is very much faster than before. So that is importance of threading. We'll make use of this threading while making the reverse shell in the upcoming lecture. So see you in the next one.